I need to find my paper here. Okay. All right, so number 2 looks like this. So what did you do first, Caroline?
I multiplied the denominators on top.
Okay, I hope first you factored that last denominator. You always want to factor your denominators. So that last one factors into x minus 3, x minus 1, which matches the other 2. So now we're going to multiply everything by x minus 3 and x minus 1. Okay? Now, what do we do that for?
So we can cancel them out.
Yep, so we can cancel them out. That is exactly right. So we're going to get rid of the x minus 1. And that's going to leave us with 2x and x minus 3. That's what's left here. Plus, okay, now this is going to go away. And we have 1 times x minus 1 equals, and then the whole mess goes away, so all we have left over there is a 2. Is that right?
Yeah.
Okay. So now we'll just do some distributor property and collect like terms. So 2x squared minus 6x. So 2x squared, these two make a negative 5. And then I'm going to go ahead and subtract that 2, because if it's a quadratic equation, if it's a squared equation, I want to have it equal to 0. All right, now what?
And factor that.
Okay, so this does factor. If it's kind of a harder factoring, if you don't want to factor it or don't see how it factors, you can always use the quadratic formula. But this does factor, because when I FOIL it, I get 2x squared minus 6x plus 1x, so that would be negative 5, and then minus 3. The parentheses give me my answer then, so my answer would be, set that equal to 0, negative 1/2, or 3. Set these equal to 0 and solve them, right? That's how we do it.
Yep.
And then we got to remember to check. What would happen if we put 3 in right here for this x? What would happen to this denominator? Yeah, and it can't be a 0. So that would be an extraneous root, and the only answer is negative 1/2. Any answer you come up with cannot make the denominator 0. So you got to get rid of them if they make the denominator 0. All right, Caroline, does that take care of your question?
Yes, thank you.
All right. So now, Jacob, it's your turn. What's your question?
Well, I was wondering if we could do some practice problem for the quiz tomorrow?
What kind do you want to do?
I was hoping we could review the it's the limit ones.
Okay. All right, so you'll have some kind of a picture already drawn. So okay, so there'll be some kind of a picture already there. And then based on that picture, you're going to figure out what the value of the limits are. What the values of the limits are. So let's say we're going negative infinity. 1 from the right side and negative 2 from the right side. Okay, so please don't make it hard, Jacob. It's so easy. You just look at your picture. This says x is approaching negative infinity. So we're going that way. That's where negative infinity is out that way. So as you follow your curve that way, farther and farther and farther, what's it doing?
Getting closer to negative 2.
Yep, from the bottom. So we'll say negative 2 from the bottom. Now, okay, if you're CP, this doesn't pertain to you. This is an academic question. So we're waiting our turn.
I'm back.
Okay, so now we're going to approach 1. So here's 1. It's an asymptote. I got to know which side I'm coming at it from. According to the problem, I'm coming at it from the right side. So here's the asymptote. Here's the right side. What am I doing?
You're going up.
Positive infinity. Yep. Same thing with that one, only now I'm looking at this asymptote, negative 2. But I'm still coming at it from the right side. So
It's
what am I
positive
doing?
infinity.
Positive infinity. Yep.
Okay. That's all I have. Thank you.
You're welcome. Okay, now William, it's your turn. What do you want to do? William?
Yeah, can we do a nice little practice problem for the quiz?
Which one?
We do one with the, I don't know what it's called, but you add one x times x minus 5 over 2 times x, we do one like that.
Yeah, I think I know what you're talking about. Takes me a minute. All right, let's give this a shot.
Good.
Our directions say solve. What do I need to do? first.
I'm allowed to work with them on this? Like, can we all work together?
No, we can all work together. We're all doing the same thing here. Yeah, we can all work together here.
You multiply by X.
Yeah, I gotta get rid of that denominator first, William. So I'm gonna multiply everything by X. Now, that is going to cancel this X out. So that's completely gone. So I have X squared minus 5X equals 6. Now I'll move the 6, like you suggested.
Yeah.
Because now I have a squared equation, and I need to have it set equal to 0.
Yeah.
So I'll subtract the 6 over. Now this is a solve equation. So I am either going to factor it, or I'm going to use the quadratic formula. Whichever one works for me, it doesn't make any difference.
Let's factor.
All right, be careful when you factor it though, because that's a negative 6. That means I need one positive and one negative.
Yeah, so 2 and 3.
It can't be 2 and 3, because look,
1 and 6.
when you FOIL, you don't get 5, because one of them's positive and one of them's negative.
6 and 1.
6 and 1. That will give me a negative 5. And it will give me my answer. So X equals negative 1 or X equals 6.
Yeah.
Right? Now, on the problem Caroline had earlier, one of those answers didn't check out, but here they're both okay. Because a negative 1 or a 6, neither one is going to give me a 0 in the bottom. So I have 2 answers. I just have 2 answers to the problem.
So, Ms. Ford,
Yes.
so after you do that, you solve, well, not solve, you kind of plug each one in for X and see if they're extraneous?
Yep. And now I only have to check the bottom, the denominator. The only way they'll be extraneous is if the denominator is 0. So you don't have to plug them into anything else, just the denominator.
So I would put X, I would put negative 1 under the denominator,
Right here.
and then it would be, what, negative 6?
Okay, but it doesn't matter, because all you're checking is, does it make a 0 down here? That's all you care about. You don't have to work it out. You just check to make sure it doesn't give you a 0. Okay? All right, so now you guys try this one. I'll see if I can make up another one here. All right, let's try this one. All right, so let's try that one. What do we do first?
Multiply by X.
Yep. So when I multiply by X, it's going to give me X squared minus 18 equals 3X. Remember, when you times by X, these cancel.
Yeah. So then you subtract the 3X over.
And when you subtract it, let's put it in the middle.
Okay.
Like this, because that's like the right order to be in.
So 6 and 3 is your factors, right?
All right. So X minus 6, X plus 3. Cause I wanna end up with a -3 there.
Yeah.
So what are my answers?
6 and -3.
Yep. Okay?
Yep.
So that's one of the quiz questions. The other one, okay, it's gonna look something like this.
What the world?
Yep. And it's gonna say find the whole.
Okay.
So what do I need to do?
We got the top distributes and the bottom distributes.
Yep, we're gonna factor everything, that's exactly right. So we gotta factor it all. So the top, how does the top factor?
3 and 4.
Yeah. What? No. No. It's
6 and 2.
So -6 plus 2. I need to change something here, make that a 12. I messed up.
basic. No.
No, I think the top is right. You factored the top right.
Yeah, the top is right. No.
Okay. Now be careful on the bottom because you have a GCF.
Yeah.
So we gotta take a 3 out. And what will we have left if we take out a 3?
X squared minus 4.
Okay, and what about x squared minus 4?
X minus 2. X plus 2.
Yep.
And cancel. Nothing.
Okay, yes, and now they cancel. And the question you were answering was, where's the hole? Well, now you know, because the hole happens where you cancel, right?
Yep.
So where's the hole going to be?
-2.
-2 comma something.
And then put it back in for X.
Yep, so we're gonna take, this is our problem, this is what we have left after we cancel out. So if we put in -2, and just do the arithmetic, we have -8 over 3 times -4, so we have -8 over -12, which, is that 2/3?
Yeah.
And that's the whole.
And this is on quizzes?
Yes. Now, while I'm here, let's go ahead and do the vertical asymptote and the horizontal asymptote, since we've already done all this work. So look right here.
The horizontal asymptote is 1/3.
Exactly. Y equals 1/3. Because you can either look here and box them in, or you can look right here and box them in. 1/3, 1x over 3x. That's exactly right. That's the horizontal.
And can you show how to find the vertical? You
Yep.
have to write it down.
William, you know, William. How do we find vertical asymptotes, William?
No, you know this. Shoot. Is vertical asymptote, that's just one, is that one number or is that 2?
That's one number. And it's x equals 2. Vertical asymptotes are what make the denominator 0. Whatever makes your denominator 0 is your vertical asymptote. X can't be 2, because if you put a 2 in there, you get a 0.
Right. Yeah. Okay. Wait, so is it? Oh yeah. So do you set the negative 2 equal to 0? Is that what you're saying? Oh, you gotta.
Whatever would make this 0. So if x minus 2 is 0, that means x is 2. That is your asymptote.
Okay. So it's the denominator, whatever makes it 0.
Yes.
And then you plug the. Hold on. Is that the final? That one you got?
That's it. It's x equals 2. You don't plug it in anywhere. You can't. The only thing you ever plug in is the whole.
I'm talking about what you got boxed in. That's the. Remember, that's where we like. That's our finished product of the whole column, right?
Yes.
Okay.
Yes. All right, you want to do one more of those?
Yeah, we can.
Let's see. All right, let's see if I got this one right. All right, we'll start off by finding the whole like we did last time, and then we'll go ahead and find our asymptotes too. Okay? So what do we do to start? All right, so tell me what. What?
I take a 2 out.
Yep, I would definitely take a 2 out. So you want to keep the 2, but now you should be able to factor what's left.
It should be 5.
3 and 5. So x minus 3, x minus 5. Order doesn't matter. All right. So far, so good. What about the bottom?
You can take a 3 out if you want to.
Okay. Oh, I definitely want to. It always makes it easier to take out your GCF. So there's a 3. What about what's left once I take the 3 out?
Yeah. No, it's 3 and 3.
X minus 3, x plus 3. Difference of squares. You got to know that one, guys. Okay, then what do you notice?
Extraneous.
Well, we're going to have a whole. Those are going to cancel, right?
Yeah. Yeah, oh my God.
So, I'm going to write down what's left, just so I have it here. But I canceled out x minus 3, which means that my whole will have an x that's what? What will the x be for my whole?
-3.
No, boys, it's always the opposite. So if we canceled out x minus 3, it'll be 3.
Oh.
Guys,
I'll put that. You should have just said what's it gonna be.
I did. I said, what is the x going to be, Farrell?
Oh, it sounded different. My bad.
Uh-huh. So the x is gonna be 3, because that's what I canceled out. Now how do I find the y?
Put the 3 back in.
Right here. So it's gonna be 2 times 3 minus 5, and 3 times 3 plus 3. So that's 2 times negative 2 over 3 times 6. Negative 4 over 18. Negative 2/9.
Yep.
You a lot of times get a fraction there, don't worry. Okay, William, are you paying attention?
Yeah, look at my notes. So
Okay.
HA is going to be -3.
The vertical asymptote is going to be x equals -3, because the vertical asymptote is what makes the denominator 0.
Okay, so vertical's the denominator. Okay.
And then to get your horizontal, you're going to box it in either at the very beginning of the whole problem, or right here, you have 2x over 3x, or 2x squared over 3x squared. So your horizontal asymptote is y equals 2/3. 2 over 3.
Okay.
Or 2 over 3. Doesn't matter where you get it from.
Alright.
Well, Mr. Farrar, I think we're ready.
Yeah.
Okay, well, we've done a couple of everything, so you just gotta be ready.
Gotcha.
Okay, you good?
Yep.
All right, I'll be here tomorrow too.
You like my medal, Miss Ford?
Oh yeah, did you all get one of those? How heavy are they?
Yeah, they're pretty heavy.
Are they heavy?
Mm-hmm.
Well, congratulations. It's kind of a bummer that you can't wear them to school
Yeah.
and show them off.
Mm-hmm.
Well, I watched it, even though it stayed on way too late for me. Oh my goodness, it was late.
That was a long 4-hour game. Miss Ford.
Yeah. Well, it didn't start till so late, but it was worth it. Congratulations.
Thank you.
All right, you guys done?
Yeah.
All right, I'll see you later.
I see you.
Bye-bye.